Okay, previously we showed how pandas does it without any programming, but it's not as simple as one button. Now we want to really do it ourselves from scratch. Okay, so let's do it in Python. We start from read files. How do we read files? Well, there are many ways to do it. You can just very simply just open toy.txt. That opens a data file, then just read lines. Read lines reading all the lines. And these are the 10 lines. Okay, you can see how many lines you've read. So just read 10 lines. Right, 10 lines. Each line is a string. At the end of that string is a kind of a new line symbol, new line character. And you want to kind of process this a little bit. What you can do is to split this line into two fields, the first field, second field, first field, second field, stuff like that. What you can do is, there are many ways to do it, and here I use a very simple way to do it. Just lambda, you want to map, you want to split each person, right? You can just say row string dot split by comma, and for s in this open, right? Right, so you now get a list of two for each row. So you really separated the first column from the second column. But this new line symbol is still at the end. That's not very nice. Let's get rid of it. You can do, let's see what better ways to do. You can strip it first, strip the beginning and end, strip the kind of not very meaningful characters such as spaces, new lines from the beginning and the end of each line, strip and split, and fluorescent. So that's this comprehension, and then you get something very nice, right? Alternatively, you can, what I want to do is data is just map lambda s dot strip dot split. So I just want to do it in a one line, in a kind of more functional way. To open toy.txt read lines. Okay, I got this, very nice format. Now let's try to map them into stuff like this, right? Like, the vectorized format. How do you do it? Well, you first need to have some mapping, right? So let's say you have a mapping, which is a hash or a dictionary. And this mapping is from kind of real features to the idea of that feature, because we'll be getting a lot more features. Like the first column will produce, say, 9 features. The second column will produce 3 features. So we'll keep a mapping, and then you have reverse mapping as well. But let's keep a mapping here, so that we can say, and let's call something like new data is empty, and that's for each row in this data set. Right, for each row in this data set. Sorry, for a row in data. Let me just erase this. For row in data, let me clean up. For row in data, for each row in this data, for j and some x in enumerate row, because I want the column index of j. Okay, what I want to do is I want to say this feature, or is basically j then and x. What does that mean? Is like column j is the column index, so initially 0, 0, 45, 1 federal government, 0, 33 is a feature, 1 private is a feature, 0, 19 is a feature, 1 private is another feature. Okay, that's the feature representation using a pair. right? So this way, I can separate all fields, right? So, so it's not exactly correct to say 19 is a feature. 19 is not a feature. Age equals 19 is a feature, or in other words, age comma 19 is a feature. Sector comma private is a feature. Education equals doctorate is a feature. Hours per week equals 35 is a feature. And it's incorrect just to use 19 as a feature because you can have age 19, you can have hours 19. Are they two separate features? Are they the same feature? Of course, they're separate features. So you have to include this column index as part of the feature, right? For other features, you probably don't have a kind of a duplicate or conflict, but for hours and age, yeah, they have a lot of common numbers like 45. You can have age 45, you can have hours 45. So you have to distinguish them, right? So that's why I have a pair as the feature representation. Now, what I want to query next is if is feature in mapping. If feature is not in mapping, that means I'm looking at a new feature I've never seen before. So for example, one federal government is some feature that I've never seen before. One private is a feature that I've never seen before. I need to add it to the mapping, to my dictionary. But the next time I see one private, I would claim that's a feature that I've seen before. Okay. Next time I see federal government, I would say, oh, that's the feature that I've seen before. It's not a new feature. I just look it up in my dictionary, in my mapping, or index, in other words. If it's not in mapping, I need to add it to the mapping. So mapping feature equals len of mapping. So this is a very nice line. So insert a new feature into the dictionary, the index. Because initially mapping len of mapping is 0 because it's empty. So the first feature comes in. Well, the first feature which comes in will have an index of 0. The second feature comes in. At the time before the second feature comes in, the mapping has exactly one guy in it. So the len of mapping is exactly 1. So it will have, the second feature will have index 1. The third feature will have index of 3 and so on. Of 2 and so on, sorry. Okay, and now my new data, new row. Let me use a new row. It's initially empty. No, this is not necessarily the best way to do it, but I would just want to do it in a very slow way. Mapping of feature, right? And then at the end of this loop, I append the new row to new data. Again, this is not necessarily the best way to do it, just for demonstration reasons. Okay, and that's it. So what's my new data? Well, my new data is, first of all, instead of string format, it's all numeric format, and now it's also kind of binarized, but not yet, not totally binarized yet. Okay, so this means I have a feature 0 for the first person, and feature 1 for the first person, and then feature 2 for the second person, and feature 3 for the second person. And you might wonder, what are these features? Well, they're recorded in mapping, and you can see what are mappings. Well, age of 19, so 0 means column 0, which is age. Age of 19 is feature index number 4, is the fourth feature. Which is the first feature? Well, of course, age being 45, because age 45 is really the first feature you encounter. So age 45 is mapped to 0, is the first feature. Sector, or first column, being federal government is the second feature, so that's the index of 1, and so on and so forth, right? So 19 is the fourth feature you encounter. Age of 30 is the sixth feature you encounter, and so on and so forth. Okay, so that's the kind of numeric encoding. But that's still not the vector format. That's kind of the binary format, but not the vector format. We want something like this, How do you convert from here to here? Well, that's relatively easy. You just populate a NumPy array, and for the first person, you just say dimension 0 being on, dimension 1 being on, everything else being empty, being off. The second person, these two dimensions being on. The third person, these two dimensions being on, and so on and so forth. So that's very easy. So binary data is numpy.array. Well, you don't need to say numpy.array. You can just initialize being 0. Okay. How many people? 10 people. How many columns? Well, how many columns? Well, that you need to ask the mapping. How many features have I? How many unique binary features have I encountered so far? 12. Okay, because there are really 9 possible ages. Right, really there are 10 people, but one age I think is duplicated. Which age is represented twice? Okay, 33 is represented twice. Okay, yeah, because a lot of people are age 33 in this workforce. And second column, there are only 3 values: federal government, local government, and private. So 9 plus 3, 12 features. So that means you need to create or initialize zeros, 10, 12. 10 rows, 12 columns, a matrix of 2D table. Okay, being data. Okay, so that's the table we want to fill in, and want to fit in using this new data table. Okay, so this is very easy to do. We'll just translate this to be on. So 0 dimension on, 1 dimension on. So the first person will have this being 1, this being 1, and so on and so forth. So let's say for row, for I row in new data, is it called new data? Yeah, it doesn't matter. It's called new data. Right. And for each column row, which is something like 0, 1, 2, whatever, what you want to do is you want to change this particular value of that dimension x. For example, 9 means the 9th feature, which happens to be age of 35. That dimension needs to be on. Okay, why it doesn't work? Well, because for I row, it should write enumerate, right? So enumerate. By the way, enumerate is one of the best tools in Python, best tricks in Python, right? So you can always have the index and this kind of data. If you only have the data, then you just can only say for row in data. But if you also wanted the loop variable, like for loop in C or C++, you want to have both. So you have this, and if we just want to print I row, let's just make an example. Right. So you have the loop variable from 0 to 9, and then the row being these rows, right? In these rows. Now let's continue. Let's just continue doing this. And for x in row, being data the ith row, and the x dimension being on. Okay, being data. Now we have exactly what we wanted. So you can just feed in this matrix to perceptron or scikit-learn. In homework 2, you can use scikit-learn. In homework 1, you have to write your own perceptron, and that's exactly what you wanted, right? And the nice thing about writing from scratch is that you can now making sense. After you train the perceptron, you have weights for different features, different columns, and I was asking which column, which weight, which feature is the most positive, or which are the most positive, which features are the top 5 most positive features, which features are the top 5 most negative features, and you can look at those weights and see the top 5 positive weights, and then you translate it back using the reverse mapping of this mapping, right? So if you say feature 320 is the most positive feature, what exactly is that feature? Okay, you look at that table. Oh, it actually is education equals doctorate, right? So you need a reverse table of that table, but that's fine. That's not not very difficult at all. Okay, so in total, you just need like something like this, right? And then followed by something like this. and that's it, right? So it's really simple, really simple, right? So we only need kind of two passes of the data. The first pass builds the feature mapping, uh, and the second pass will just translate it into NumPy. Okay, the little difference you might have observed is that this format is slightly different from the pandas format which we had here. So if we have concatenated, so if we remember np.concatenate pandas.getDummies f of h np.array and np.array pd.getDummies f of sector. There's so many parentheses and then forgot another one. There's so many parentheses here. It's very easy to get lost. Axis is 1, right? So they're the same dimensionality, right? 10 rows, 12 columns, but slight difference, very small difference that you might have noticed. Here, the first feature means age of being 45. You can look at it. And the first feature being age 45. The second feature means sector is federal government, right? Because these are the first two features we encountered by scanning through the dataset. Now here in the pandas format, these first 9 columns or not first 9 binary features are the age, and the last 3 columns or last 3 binary features are the sector column, right? So they actually group them together, right? In other words, in pandas implementation, they would scan the first column first, build up the feature map for the first column, encounter all possible ages, and then scan the second column, encounter all possible sectors, then scan the third column, blah blah blah. So that's why they have a more kind of separation, but it doesn't matter really. Perceptron doesn't need to understand what's the meaning of the first dimension. To a machine learning algorithm, the first dimension is just a dimension. Whether it means age being 45 or a sector being local government doesn't make any difference. So after you have converted the dataset to a NumPy vector format, everything looks exactly the same. Perceptron, it just understands your dataset as points in the higher dimensional space. Points in this case in about 230 dimensional space for homework 1. In our very small example, it's only 12 dimensions, right? But perceptron doesn't make any difference between the dimensions. They're just all same dimensions. It's only your conversion kind of injects semantics, injects meaning into these dimensions. Oh, the first dimension is age being 45. Those are stuff coming from your conversion. So that's again another reason that we ask you to do it manually, because you see a lot more stuff than as if you just call this pandas.getDummies. You really getting only dummies, right? So you don't have any of these internal insights of this conversion, or how do you convert a real data set into high dimensional vectors. Okay, so I hope this tutorial is helpful, and you need to still do a lot of work yourself. Right.